All right, guys, I just handed out to you the notes for section 5.3. We will spend today and tomorrow learning the new material. Thursday, we'll spend reviewing all of it, and then we're going to take a quiz on Friday over it. Just over this section. Yeah. So Friday's quiz is just over what I'm teaching you today and tomorrow. Okay, and we're going to review it Thursday. We're going to quiz over it Friday. Because it is so important that you know this, we're going to spend, you got to get this spot. Okay, this stuff. Cool. Your quizzes are graded. They're in the grade book. I will show them to you at the end of class today. I can't let you keep them and hold on to them because not everybody's taken it yet. But I'll let you see them. Not everyone's taken that yet either. I know, right? I know. No. Nope. I don't hand them. I don't let you keep a hold of them until everyone's done because for obvious reasons. The quiz from yesterday? Oh, the tests are graded. Quizzes from yesterday are graded. They're graded. Oh. Yeah, so they're in the grade book. They're in there. All right, here we go, guys. This section that we're focusing on this week is factoring again. We've done factoring, right? Today shouldn't be too bad. Today's just we're going to spend some time reviewing what we've learned from factoring before to get you in the right mindset. And then we're going to kind of take it one further. We're going to look at x to the fourth, how to factor those today. Everything we factor has always been x squared. So today we're looking at x to the fourth. That's funny. Anyway, back to what we're doing. Tomorrow we're going to learn how to factor things with 4 terms instead of just 2 or 3 terms. And then we're going to learn how to factor sum and difference of cubes. So x cubed tomorrow. Eventually. A couple sections from now. A couple sections from now. Mm-hmm. Yeah, sometimes the directions aren't real clear. Thanks for coming. Here you go, hon. All right. Guys. Thank you. No. All right, so here we go, guys. So we're looking at factoring for today. All right, step by step through here. To factor a polynomial equation, first move all terms so that the equation equals what? 0. No, pay attention. Always remember to factor out the blank before doing any other. That is GCF. If you like to fill the whole line, you could write greatest common factor. I know that bothers some people because the line's so long. I'm going to write GCF just because I'm lazy. Yeah. All right. Once the equation has been factored, set each factor equal to blank and solve. 0. We set them equal to 0 and we solve them. The blank of the polynomial is equal to the number of solutions or zeros. The exponent, which is also known as the degree. There it is. Thank you. Degree, which is your highest exponent. If an equation cannot factor completely to linear factors, so you're all the way down to like x plus a number or whatever, right? Just a single x, not an x squared, x cubed, whatever, then you'll have to use the quadratic formula or finding square roots when necessary. So this is going to be new for us right here. Because there's times where you're factoring and you're trying to work through a problem and you get to a point and you're like, I can't factor that any further. It just doesn't factor. So you're still supposed to solve, so what do you have to use? Quadratic formula, or if there's no bx term, you can just use the square root method, okay, to solve. So all that stuff from chapter 4, it's coming back again. All the factoring, square root method, quadratic formula. The only method that doesn't really come back, completing the square. Yeah. You're okay with that? Solutions or zeros may be blank or blank. Very nice. No one ever gets that one. Awesome. Real or imaginary? Most people say positive or negative. Which is true, but that wasn't what I was going for. So thank you, Josh. And then watch for factors that are not linear. They may factor further. Okay, so just be careful. Sometimes you're like, yeah, I'm done factoring. No, you're not. You can keep going. All right, so a lot of that was new. The big thing is right there. You might hit a point where it doesn't factor, but we still have to solve. So you may have to use another method. All right, so here we go. We're going to kind of start back at basics. We know how to factor, right? Well, some of us. What do we... Number 1. That just made my day right there. All right, here we go. So solve by factoring. It's already set equal to 0. Is there a GCF? 2x. Let's take out the 2x. So we're left with x squared plus 4x plus 3. Yeah, this one's not too bad. We're going to kind of start a little small, kind of baby step into this like I always do with you guys. Does that factor further? Yes, it does. Guys, if I still have an x squared, I'm going to try to factor that thing further. Say that again? Oh, I did not think you said 1. Yes. I thought she did too. That's why I was like, say that again? Yeah, that's perfect. So x plus 1 and x plus 3. What do the directions say? Solve by factoring. If it had said write in factored form, you'd have been done. But notice we have an equal sign. We're actually solving. So we set each factor equal to 0. And I know most of you can do this in your head, but just make sure we're clear. Because we're going to hit a point where I can't do them in my head any longer. Just know that that's coming. Okay? I want to make sure we're clear on the... Yeah. All right, so what does x equal here? 0. X equals -1 and -3. I have 3 answers. Did you know that was going to have 3 before you started? Good. That's a third degree. X to the third. So we knew we should have 3 answers. All right, how about number 2? What do you have to do with that one first? I'd probably move the 5 and the 12. Because otherwise I got to take out a negative. I don't want to do that. Yeah. If I can avoid that first term being negative, that'd be better. So 2x to the 4th. We're going to subtract over the 5x cubed. You want to subtract over the 12x squared. Very good. GCF, I can actually take out an x squared this time. A lot of you guys kind of get stuck. You stop looking for those variables. We need to always make sure we're looking for those. All right, so taking on x squared, we have 2x squared minus 5x minus 12. I can keep going. There's an x squared. I should try to factor that further. All right, so x squared. Set up my parentheses. What are your signs? Options for A. So 1x and 2x. Options, ooh, 12. 3 and 4. All right, so this is one I'm going to have to kind of check a little bit. Is there one of those options you can eliminate right away? All right. 1 and 12, hopefully you can kind of play around with the numbers and see that that one's not going to work. This one right away, how do I know this one doesn't work? If I would put either the 2 or the 6, I've made a GCF here. There is no GCF up there, not a number. So I know that there shouldn't be one down here. So can the 4 go here? No, I'd put a GCF in there again. So it's got to be that way. How'd I do? My signs are wrong, right? Because this gives me 8x minus 3x. That makes positive 5x. I need negative. So that should be the plus. This should be the minus. That way when I check this, I get negative 8x plus 3x. I need this to be a negative 5x. If I had my signs flipped, it gave me a positive 5x. Yes. Stop it. It's awkward looking, but no, it's not wrong. All right, from there we need to solve, right? So what does x equal here? 0, 0. Here? Good. I have 4 answers. My original problem was x to the 4th. Please try to do that mental check. This chapter especially, look back up there, see what the exponents are, and kind of go from there. All right, how are we doing so far? Pretty good? They're cute, aren't they? Yeah, you guys want to try 3? Yeah, try 3 on your own. We'll see how we do. All right, let's talk through this. So what's the first thing you did? Good. Move the 6x. Good. Take out a GCF of 3x. I forgot to divide it. 4x. Hey, we all do that. All right, so then you tried to factor from there, right? And it doesn't factor. But I'm still supposed to solve. True or false? I can solve anything with the quadratic formula. Justin, you said false. Why'd you say false? It doesn't sound right. If it has, very nice, Peyton. If it has an x squared, I can factor it, or I can use it. The quadratic formula. It doesn't factor, so we're going to use the quadratic formula. But guys, the quadratic formula, I need to make sure you're clear on this. You can only use the quadratic formula on a quadratic equation. I have this down to an x squared, which is quadratic. Now I can use the quadratic formula. I can't from the beginning because it's x cubed. It's not a cubic formula. It's called the quadratic formula. Well, did you factor? Is taking out a GCF factor? Yep, sure is. Yes. Okay. What does x equal here? 0. So x equals 0. There's one of my answers. And to get the other 2, this doesn't factor. Let's go to the quadratic formula. So thank you. So negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Would it make you more comfortable if I... Oh, my line doesn't match up. Is that better? Oh, stop it. It's not supposed to cover the x. It's not supposed to. This is x equals. That's the answer. This is... I'm not dividing this x by something. That's what I'm solving for. So x equals negative 4 plus or minus square root. What do we get underneath there? 56 over 10. All right. What about now? Okay. Can I do a factor tree? What's 56? So 2 and 28. Why would you go 3? 2 and 14. 2 and 7. No. So we get x equals negative 4 plus or minus, what do we get here? Over 10, that's what I heard. Good, these all can be divided by 2. So x equals, divide by 2. She did well with the quadratic formula. All right, whew. It was, so don't we wish it just would have factored? All right, but do we have 3 answers? How many is this? This is 2. One's positive, one's negative, and 0. There's 3 answers. All right, so as you're going through these, you get to a point, you pull out your GCFs, you see what you got, and it doesn't factor, but it's x squared. You're going to have to go to the quadratic formula. Then at this point, you probably did something wrong because everything should at least get that far. Later on, I'll show you what to do when it doesn't. All right, how about number 4? Now you're afraid of doing by yourself, aren't you? All right, we'll do it together. Let's move the 3x. All right, so set it equal to 0. GCF? Just an x. 2x squared minus 5x minus 3. Bless you. This is an easy one. What are your signs? Signs? Opposite, thank you. Options for A? 1x, 2x. Options for 3? 1 and 3 or 3 and 1? 3 and 1? We're not sure. Let's check it. So we get 6x minus 1x. That's 5. My signs are backwards. So that one's positive, this one's negative. Yeah, that one actually factored.
Oh, of course, we get the easier one.
You guys asked.
Yeah, but you used it.
I did.
You did that on purpose, probably. You like switched around.
What does x equal? Beautiful. As a team, you guys are fantastic. You guys want to try 5? Give it a shot. Let's go with 5. All right, here we go, guys. Number 5. Guys. All right, number 5, Noah. You're embarrassing yourself, so let's change the subject here. All right, so we took out the GCF 3x squared. Does that factor? No, it doesn't factor. So what do you have to do? Quadratic formula. So x equals 2 plus or minus square root negative 2 squared minus 4 times 1 times 4 all over 2 times 1. So 2 plus or minus square root, what do we get? Negative 12. All over 2. All right, from there, what does that become? You have to take out the I. Yep, so you're going to get 2 plus or minus, good, it's going to be 2I radical 3 all over 2. Good? Or keep going? Keep going. They can all be divided by 2? Is this 1 necessary? First one, yeah. That's adding and subtracting. That's necessary. 1 plus or minus, is this one necessary? No. So it's just I radical 3. 1 on the bottom necessary? No. How many answers do I have right now? I have 2. I should have 4. Where's my other ones? Good. I have 0, 0 up here. 0, 0. Making sure we don't forget that. That's why you guys do that mental check, because I see that a lot. Students pull it out, like the 3x squared. They're doing fine, but then they just forget to write down 0 and 0. Your other 2 answers. All right. Questions so far before we kind of switch gears just slightly? Yes. This one, if I add $1 to your pay, does it change how much you get paid? So it matters. Yeah, that one's necessary. Versus if I would multiply your pay by 1, does that change how much you get paid? I'm going to multiply it by 1. That doesn't change anything. So that doesn't matter there. But here, that one matters. You're like, thanks. All right. Difference of squares. This part is not new. However, for whatever reason, a lot of you stink at these. I don't know why. I don't know why. All right, so number 4. Same rules apply. Set it equal to 0, right? So 12x cubed minus 75x. For whatever reason, you guys panic when you see these, and these should be the easiest ones there are to factor. All right, what's your GCF? 3x. 3x. So we're left with 4x squared minus 25 equals 0. Difference of squares. Do you see the difference? The minus sign. Perfect square, perfect square. Difference of squares, guys. What are your signs if your last one's negative? Plus and minus. Square root of 4x squared. Square root of 5. Can we solve? We sure can. X equals 0. And then plus or minus 5 over 2 because I'm lazy. Negative 5 over 2, positive 5 over 2. I'm just lazy and wrote it all together. I'm just lazy. Why don't you guys do the next 2 on your own? Next 2. Next 2. Together. All right, number 5. Stop speaking. All right, so it's already set equal to 0. GCF? X squared. So we have 9x squared minus 64 equals 0. That's a difference of squares. 1's plus, 1's minus, 3x, and 8 and 8. Square root of 9x squared is 3x. Square root of 64 is 8. All right, even if, okay, you stink at that option. Think about it this way. What's your B term? 0. So you want to be able to check this and get 0 in the middle. So there's 24x minus 24x. It cancels out, so I know it works. That's a 4.
Okay, Miss Silver, I have a question.
Yes?
Is it coincidence, or is it not, because I took 3x squared out?
You can't.
I got the 3x minus
You
3.
cannot take out a 3 because 3 does not go into 64. No, it doesn't. I love how you doubt me.
I mean, technically it goes in 21 times. 0.3333.
What does x equal? Plus or minus 8 over 3. Negative 8 over 3, positive 8 over 3, negative plus. Just to annoy me? Sure.
So I accidentally put in 24 divided by 3, so I got the 3x minus
So it's not coincidence, you just typed in the wrong thing.
Yeah. Hey, at least I got one part right.
Your work would be all wrong. All wrong. Number 6. Friday? The quiz Friday is over what I'm teaching you today and tomorrow. A lot of this, yeah. I know, right? All right, so here we go. Number 6, subtract this over. So we get 100x squared minus 81 equals 0. Is there a GCF? No, and there's not in this one. 10x, 9. So x equals plus or minus 9 over 10. Yeah, we're time for one. All right, so here's all, most of this we've seen before, other than the ones where we had to use quadratic formula, right? So we're going to switch gears. We are going to take a little brain break. But we're going to switch gears on looking at when it's not x squared. Because notice here, when I set this one equal to 0, can you take out the x's so you have an x squared? You can't. So we're going to talk about how to go ahead and factor and solve these. All right, so if I have x to the 4th plus 2x squared equals 15, first thing I have to do, bring the 15 over. Can I take out an x? I cannot in this case. However, I want you to look at something. Back on these problems, once we pulled stuff out, you had an x squared, And then your next one was an x, right? What's the exponent on this? 1. What is the relationship between 2 and 1? 1 is half of it. So if I come back here, I have a 4 and 2. What's the relationship? It's half. As long as your next exponent is half, this totally works. Okay, let me show you. So when we go to factor, because there is no GCF, your last one's negative, so they're opposite. Instead of x squared being x and x, it's going to be x squared and x squared. 7. Well, let's kind of talk about that. Okay, so we'll do x squared and x squared, right, because we're just splitting this. Now if I go to multiply this together, do you see where the x squared is going to come back? 15? 3 and 5, which one's positive? The 5, right, because 5 minus 3 is 2. So there it is factored. So factoring, was it that much different? No, not really. But instead of it being x and x, it's now x squared, x squared. But think about how this changes your answers. So if I write, let's go that same idea, right? We set them equal to 0. And we have to solve, right? So if I subtract my 5, I get x squared equals negative 5. How do you get x by itself? Take the square root. So x equals plus or minus I radical 5. Right, because there's a negative under there. Don't forget your plus minus, because, yep, that's 2 answers. So, no, just radical 3. Because I have to add the 3, so it becomes positive. Take the square root. So x equals just plus or minus radical 3. How many answers did we get? We got 4, right? 1, 2, 3, 4. I should have 4. So is it the same process as before? Same process. But when I get to this point and I go to solve, it's a little harder to do the mental math. Some of you will probably be able to still do this in your head, which is great. If not, write it down, okay? I will always show my steps here. Me personally, I do them in my head, but when I'm teaching you guys, I'm not going to skip these steps. I'll show them. Noah? Then you have to rationalize your denominator. Yep, yep. So let's take a look at number 8. It could be 6 and 3. However, what we're dealing with, do you know how to take cubed roots of things yet? Yeah, so what we're doing, they're going to be 4 and 2. Just because we know how to solve things that are x squared by taking square roots. We haven't talked about cubed roots, fifth roots, any of that crazy stuff. Yes, chapter 6, we'll talk about that. All right, so 3x to the 4th, we need to move this over. Minus 13x squared plus 4 equals 0. Is there a GCF? There is not. Nothing goes into all of them. I can't take an x out because they don't all have x's. All right, so let's, what are your signs? Two minuses. There we go. We got there eventually. Good. We're going to have 1x squared and 3x squared. It'd be 4 and 1. Good. Right, because this gives me negative 12 minus 1 makes negative 13. This is just like what you were talking about fractions. It's going to show up here. All right, so x squared minus 4, we're going to set that equal to 0. 3x squared minus 1 equals 0. And we're going to solve each one. All right, so we have to add 4. X squared equals 4. Then what? Square root. Plus or minus 2. You took the square root, so that's where your plus minus shows up, right, Josh? Don't just stick it randomly wherever. All right, over here. He knows what I'm talking about there. So we have to add 1. You're doing things in your head. That's good. Divide by 3. So x squared equals 1/3. This is where Noah was talking about. He's not happy.
No, it's this I'm fine with. It's just when it becomes a negative 3. Then you gotta do the time.
You have to right here.
What? That's positive.
The negative would give me the I, but I can't have a radical in the bottom. So x equals plus or minus, what's the square root of 1? 1. Square root of 3? Can't leave that there. Top and bottom by radical 3. So plus or minus. Good. Look at you guys go through that process now, like, yeah, whatever, and you're good. But you remember when you first started, you're like, oh, how do I do this? Isn't that great, though, like how it progresses over time and it becomes easy to you? Yeah, that one was a lot of work. The calculator, you could find that answer in decimal form, but you couldn't find it in radical form. And the imaginary ones, you can't find on your calculator. Later this chapter, I'll show you how to use your graphing calculator to help you with this, but doesn't always help. All right, number 9. What do you recognize that as? Yeah, it's like a difference of squares. Technically, it's x to the 4th, but so same process as before. What are your signs? Plus, minus. Square root of 81 x to the 4th. Good, 9x squared. Square root of 121. Okay, so there it is factored. Let's set each one equal to 0. So 9x squared plus 11 equals 0. 9x squared minus 11 equals 0. Yeah, subtract the 11 here. I'll do one at a time. What do I do next? Divide by 9. So x squared equals negative 11 over 9. Square root.
So you got time.
Top, bottom. Hold on. So I get plus or minus. On the top, what happens? I radical 11 over 3. I don't have a radical on the bottom. It looks like it, but what's the square root of 9? It's 3. So I really don't have a radical on the bottom.
I like that one.
Yeah, it's nice when there's a perfect square down there. All right, over here, add 11. Divide by 9.
So it's gonna be the same exact problem, just without time.
Good. Yep. So plus or minus radical 11 over 3. You're right. It's just like that one, but one has an I and one doesn't. On difference of squares? Yes. No, that's fine. Yeah, that's fine. Number 10, think we can do it? Yeah, try number 10. Try number 10 on your own. All right, guys, let's take a look at number 10. It's already set equal to 0. What type of factoring is it? It's like a difference of squares. Yeah. So what are your signs? Plus, minus, square root of x to the 4th? Square root of 16? And again, if you're not comfortable with difference of squares, think about it as what's your b term? 0. So double check your work, make sure you get a 0 in the middle. Okay? All right, so we set each one equal to 0. And we solve. So we have to subtract 4. And then we take the square root. So x equals plus or minus 2i. So x squared equals 4 square root. X equals plus or minus 2. Good. Questions so far? We got 2 more examples to get through, and then we'll be good for the day. All right, last 2. We'll do them together. We'll do them together. Be all right. So number 12, what do you do first? Subtract the 4. All right. GCF? No. Good. I cannot take out a GCF, so I got to try to just factor them. Signs? Right. Plus minus. Options for x to the fourth? X squared, x squared. Options for 4. 1 and 4. No, you were at 1 and 4, because this gives me positive 1 minus 4. So I wanted the negative, so you're good. Yeah, you're good. All right, so we set them equal to 0. X squared plus 1 equals 0. X squared minus 4 equals 0. So subtract 1. X squared equals negative 1. Plus or minus 1i, technically, but I. Just plus or minus I, and that one's fun. And then x squared equals 4. Square root plus or minus 2. Again, if you get in that habit of doing that mental check of how many answers am I supposed to have, hopefully that reminds you that you're probably missing a plus minus if you don't have all your answers. Okay, so we should have 4. What's wrong with the next one? Am I? So x to the fourth plus 4x squared minus 12 equals 0. GCF? No? Could I use the quadratic formula on that problem? It's x to the fourth. I cannot use the quadratic formula. So at this point in this class, you should be able to factor these. Because if it didn't factor, you can't use the quadratic formula and you wouldn't know another way at this point how to solve it. You will as the chapter progresses, but right now you don't, so it'll factor. Signs? Thank you. X squared and x squared. 12? Good. It is 6 and 2 in that order.
X minus 2 is positive.
Yep. Set them equal to 0. X squared plus 6 equals 0. Where somebody's confused? If we check this, this gives me 6x squared minus 2x squared. I want positive 4. Are you? All right, subtract 6. So x squared equals negative 6. No. X equals, I agree with your plus or minus. I radical 6. I can't take the square root of 6. There's no factor tree I can do. I don't think it gives me any pairs, so it stays underneath. But I do have to pull that I out of there. Over here, x squared equals 2. Square root. So x equals plus or minus radical 2. The square root of 2 is not 2. It's got to stay underneath there. Need to work on your radicals, Noah. All right.